Right class, now we start chapter 5, improper integrals. Okay, look at topic 1, evaluation of limits including L'Hopital's rule, limits of indeterminate forms of type 0 over 0 and infinity over infinity. So this topic, we're gonna evaluate the limits by using L'Hopital's rule. Okay, so let's say we have a question. Limit x approaching to infinity x squared over exponent x. Okay, this is from my question. Okay, let's say and then we do a direct substitution. Okay, we know that x approaching to infinity, then that means this infinity we need to substitute into x. Okay, it will become infinity power 2 divided by exponent infinity. So infinity power 2, it is infinity. Exponent power infinity, it is infinity also. So infinity over infinity, this is we call as indeterminate form. Okay, indeterminate form. Okay, whether infinity over infinity or 0 over 0. Okay, when we found these types, okay, these two types, infinity over infinity or 0 over 0, okay, then we can apply L'Hopital's rule. Okay, L'Hopital's rule. So the general form of L'Hopital's rule here is limit x approaching to c fx over gx. It is equal limit x approaching to c f prime x divide g prime x. Okay, from this function fx, we need to differentiate. From this function gx, we need to differentiate also. Okay, we need to differentiate these two functions. Okay, so this is we call as L'Hopital's rule. Okay, this is concept L'Hopital's rule. Okay, so back to this question. Okay, we found this infinity over infinity indeterminate form, then we can apply L'Hopital's rule. Okay, so we need to differentiate. Okay, this is fx, let's say this is fx, this is gx. Okay, we need to differentiate. Limit x approaching to infinity, differentiate x squared, we get 2x over differentiate exponent x, we get exponent x. Okay, and then try substitute again infinity into this x. Okay, so infinity times 2, we get infinity also. Exponent infinity, we get infinity also. So we still get indeterminate form, then we can apply L'Hopital's rule again. Okay, that means we need to differentiate again. So limit x approaching to infinity, differentiate 2x, we get 2 over differentiate exponent x, also exponent x. Okay, and then when we found this fixed number, okay, then we can apply this infinity. Okay, we can apply this limit. Okay, x approaching to infinity. That means 2 over exponent infinity. Substitute infinity into x. Okay, sebab yang dua kat atas ni dah fix. Okay, constant number. Okay, so no need to differentiate again. And then 2 over exponent infinity. Exponent infinity will become infinity. So 2 over infinity. 2 over infinity, it is equal 0. Okay, let's say in properties, okay, in properties 1 over infinity, it is equal 0. So any numbers when we divide it by infinity, it is equal 0. Okay, but what if infinity over 2? It is infinity. Okay, jangan terbalik nah. Okay, 1 over infinity or any numbers divided by infinity, it is equal 0. Okay, when we found infinity over 2, okay, divided by any numbers, it is equal infinity. Okay, why? Because this one is denominator, this one is numerator. Okay, numerator, denominator. When we have denominator, it is infinity. It could be a large number. Okay, but we don't know what the number it is. Okay, it could be a large number. So when we have numerator with small number compared than denominator, so the answer would be 0. Okay, boleh faham now? So the answer is 0. Okay, this is how to evaluate the limits by using L'Hopital's rule. Alright, so look at example 1. Okay, example 1. Number 1, limit x approaching to 0 sin x divided by x. Okay, so we need to do a direct substitution first. Okay, substitute 0 into x. So sin 0 we get 0. Okay, 0 masuk dalam x ni, it will be 0. So 0 over 0. So we found this type of indeterminate form. Then we can apply L'Hopital's rule. Okay, so how to do a L'Hopital's rule? We need to differentiate both function. Okay, so limit sin x over x, it is equal limit x approaching to 0. So differentiate sin x, we get cos x. Okay, differentiate x, we get 1. Okay, when we have fixed number, then we need to stop differentiate. Okay, substitute 0 into x. Okay, it will become cos 0. So cos is 0. Okay, awak calculate cos is 0, you will get 1. So this is the answer. Okay, you found now? And then look at number 2. Okay, limit x approaching to 1. Okay, 6x cubed minus 4x squared minus 2 divided by 2x minus 2. Okay, do a direct substitution. Okay, substitute 1 into x. Okay, so 6 minus 4, we get 2. 2 minus 2, we get 0. And then substitute 1 into this x. Okay, so 2 minus 2, we get 0 also. So 0 over 0, it is the type of indeterminate form. Then we can apply L'Hopital's rule. Okay, we need to differentiate. So limit x approaching to 1. So differentiate this one first. Okay, at the numerator, 6x cubed. Okay, differentiate, we get 18x squared. Okay, ingat lagi tak konsep differentiation? Okay, minus, okay, differentiate 4x squared, we get 8x. Okay, 2 times 4, we get 8. And then x, 2 minus 1, we get 1, power of 1. Differentiate negative 2, we get 0. So no need to write. Divided by, okay, differentiate 2x, we get 2. Differentiate negative 2, we get 0. So this is fixed number. Okay, so no need to differentiate again. We can apply this limit. Okay, substitute 1 into x. So 18, 1 power 2 minus 8, 1 divided by 2. Right? So 18 minus 8, we get 10. 10 divide 2, we get 5. So this is the answer. Okay, you found now? Number 2. Number 3. How to do a number 3? Limit x approaching to 0 cos x plus 2x minus 1 divided by 3x. So we need to do a direct substitution first. Okay, substitute 0 into x. Cos 0 is 1. Okay, 0 kalau kat sini 0 times 2 is 0. So 1 minus 1 we get 0. Okay. And then 0 times 3 we get 0 also. So 0 over 0 is, it is the type of indeterminate form. Then we can apply L'Hopital's rule. Okay, limit x approaching to 0. So differentiate cos x, we get negative sin x. Okay, you need to remember basic trigo. Okay, how to differentiate cos, how to differentiate sine. Okay, and then differentiate 2x, we get 2. Differentiate negative 1, it is 0. Differentiate 3x, we get 3. Okay, this is fixed number. Then we can apply this limit. Okay, x approaching to 0, that means we need to substitute 0 into x. Negative sine 0 plus 2 divided by 3. Okay, sine 0 it is 0. Okay, awak tekan calculator, sine 0 you will get 0. Okay, so the answer is 2 over 3. Okay, nampak lah? Faham lah? Okay, last one. Number 4. So number 4, limit x approaching to infinity, exponent x divided by x cube. Okay, then try do a substitution. Okay, infinity, substitute infinity into x. So exponent infinity we get infinity, exponent power 3 we get infinity power 3 we get infinity also. So infinity over infinity, it is the type of indeterminate form. Then we can apply L'Hopital's rule. Okay, so limit x approaching to infinity, differentiate exponent x, we get exponent x. Differentiate x cube, we get 3x squared. Okay, so try do a direct substitution. Okay, we still get infinity over infinity, right? So we can apply L'Hopital's rule again. Limit x approaching to infinity. So differentiate exponent x, we get exponent x. This one, 2 times 3, we get 6. Okay, differentiate 3x squared, that means 6x. Okay, and then still infinity over infinity, right? Okay, substitute infinity into x, we still get infinity over infinity. Then we need to differentiate again. Okay, so exponent x differentiate, we get exponent x. Differentiate 6x, we get 6. Okay, and then so this is fixed number. Okay, then we can apply this limit. Okay, substitute infinity into x, exponent infinity over 6. Okay, so exponent infinity, it is equal infinity divided by 6. Okay, so remember infinity, when we divide any numbers we still get infinity. So this is the answer. Okay, boleh faham lah? Tak faham boleh tanya dalam WhatsApp. Okay.